Hello and welcome to Empowered Learning. This video will be about interval notation and being able to take a set and write it in interval notation. So the first thing that I have here is just a slide on all the different possibilities of, interval notation. We also have the set notation for it and what it looks like graphically. And so we'll quickly go over this and then go over some examples. So we know that anytime we talk about interval notation, we either have it in open intervals, closed intervals, or half open intervals. So we'll just look at this first example here. So we see that when we have a purely open interval, what that means here is that we have parentheses on either side. And to give you a quick example, let's say we want all the numbers that are strictly in between 4 and 6. So this is what that would look like. If we put this in interval notation form, we would say that x is going to be from 4 to 6. And it'll look like this. Okay? The parentheses are telling us that we do not include the endpoints. So in other words, the end values. So a valid value for x would be 4.01, 4.1, 4.2, 5.5, 5.999, but we cannot say that 4 could be a value for x, and we cannot say that 6 could be a value for x. But anything strictly in between it can be that. So that's what this particular situation is saying. Now, if we were doing a closed interval, then the difference would be is that now we would have less than or equal to here. And now our parentheses here would turn into brackets. And so the brackets mean that we can include the endpoints or the end values, whereas with the parentheses, we cannot. Okay? So a half open interval would be like, let's say we wanted to include the 4, but not necessarily include the 6. So in that case, I'm going to go ahead and erase this and look at this again here. So in that case, what we would have is we can include 4, but not include 6. Okay? And of course, this other half open interval was just the same thing, but it switched around. So we would have this, but not have, we would include the 6, but not the 4. And so of course, that means that the parentheses and brackets would change here. So I'll come here, and now we would have the bracket on the 6 and parenthesis on the 4. And let me erase that and make that look a little nicer, like that. Okay, so once we get to this version of the open interval, this would be like saying I want values of x that are greater than 4. So in this case, I would write that in interval notation as 4 to infinity, that way. And so I'm teaching this as if we're in the Western hemispheres where we're reading from left to right. If you are in an area or region where you actually read from right to left, then everything that I'm saying here would be reversed, okay? Now, of course, with the half open interval, if we wanted this to be all values of x greater than or equal to 4, then we would have it like this, and now our parenthesis would turn into a bracket. And then, of course, for the last example here, this would be something like x is going to be less than, let's say, I'll just say positive 4. And so then we would go negative infinity and then 4 and then parenthesis like that. So these are the basic rules about writing sets of numbers in interval notation. We're going to move on to the next page and do some examples. All right, so we see that for our first set here, we have the set of all x such that x is strictly in between -4 and 5. We don't include -4, but we do include 5. So you see that when we write this out, it'll just be interval notation with parentheses on -4, comma 5, and 5 has the bracket. And this is what it would look like if we were to draw it graphically. Okay. Moving on to the next example, we see that here this is set of all x, and this line means such that. So set of all x such that x is less than -3. So in interval notation, this would look like this. And if we were to draw it out, it would look something like this. And we would have parentheses there, be going like that. All right, so let's move on to our next example here. We see that now we have the set of all x such that x is greater than or equal to 4. So this greater than or equal to sign lets us know that we're going to use a bracket. And here we see that since we're just saying it's going to be a number that's 4 or higher, then of course we write that on to infinity here. And this is what it would look like graphically if we were to draw the solution set on a number line. For the next example, we see that we have the set of all x such that x is less than or equal to -2, or x is greater than or equal to 1. So this is what is called a disjunction. And so you have two sets that are separated from each other, and we need to union them together. So that's why you see this U here. That's the union sign. Of course, x is less than or equal to -2. This is what that looks like in interval notation. And of course, just for that piece, we see that this is what it would look like graphically on a number line. And then for the x is greater than or equal to 1, of course, that means it's going to be 1 or higher. The bracket tells us to include the 1 in that actual set. And of course, we have the bracket here. We go in this direction. And since these two sets are disjointed, then how we bring them together is via a set operation called the union. And so we normally put this U in here in the middle to say that, hey, I know that I can pick from either this set or this set, and it will satisfy the conditions of this set. All right, so in our next example, we see that we have the set of all numbers W, where W is greater than 3, or W is less than or equal to 1. So we're going to draw this out first. So we know that we're dealing with 1 and 3. And we know for W, it's going to be 1 or less. So we would have bracket here and going in this direction because it's 1 or less. And for W is greater than 3, since it's just greater than, we will have parentheses. So we have parentheses here, and then we will be going in this direction. And so now when we write this out, notice that the way that I draw it on the number line is the way that I write it out. So here I'm going to write this set first because according to how everything is ordered on the number line, this would come first if we're going from left to right. So this would be -infinity to 1 with a bracket. And then the or here means that we need to put a union sign. And then 3 to infinity, we need to have parentheses because we can't include 3, comma, infinity, and put parentheses there. Now, one thing that I did not mention earlier, but I want to mention it now, is that anytime we have a situation where we have intervals that involve infinity, whether they look like this, like this, like this. Oops, let me do with a bracket here, or like this. We never put brackets on an infinity sign, whether it's positive or negative. The reason for that is that whenever we have brackets, brackets basically say that we have a quantifiable number that we can stop at. And of course, infinity is a concept, it's not necessarily a number. So because of that, we never put brackets on infinity because we don't know how much infinity actually is going to be. All right, so moving on to example F. We see that this is the set of all numbers y, where y is strictly in between 10 and 15. So if we were to draw that out, that would simply look like this. We want numbers that are strictly in between 10 and 15. So we would have all these numbers in here. If we were to write this out in interval notation, it would just look like this. Parenthesis on either end and 10 and 15. All right, so now if we wanted to express the set of all x where x is all real numbers, then of course this would just look like this. So all real numbers, we go all the way from negative infinity to positive infinity. And of course on a number line, that would just look like all the numbers here. So we would draw something like that. And so that one's actually the easiest one out of all of these. All right, so now looking at our last example, we see that we have the set of all numbers b, where those numbers are either less than or equal to -5 or it's equal to 7. And so you see for this portion here, it's either 5 or smaller. So that goes along with this graph here, and b equals 7. That means that we have just that particular number there, and that is it. So translating this first set here into interval notation, we see that we go from negative infinity to 5. Of course, we have a union because there's some space in between this set of numbers and that number. And since we just have one number here, it is acceptable for us to write the set braces and just put a 7 there. Some people also accept the brackets on either side. This is probably the more correct way to do it, but depending upon where you're learning this from and how the textbooks work, the brackets on either side are also acceptable. And so this concludes the video on interval notation. Thanks for checking this out, and check out some of our other videos.